Here's an example of a problem involving mixing two substances. How many liters of each of 15% acid and 33% acid solution should be mixed to get 120 liters of 21% acid solution? In other words, we're mixing two liquids. Each of them contains some acid. One of them has 15% acid, the other 33% acid. We want to mix them in such a way that the result we get is 21% acid. And we want to get 120 liters of that final result. Okay, to answer this question, let's first draw a picture of what's going on. We have two substances that we're mixing to get a third substance. Okay? And what we know is that the first substance is 15% acid and the second substance is 33% acid. And what we want to end up with in the end is something that's 21% acid. Okay? Now, what do we know about the amounts? Well, we know that we want to end up with 120 liters of our end product. Okay? We do not know how much of each of these we have. In fact, that's exactly what we're trying to find. So, we can let our variables be the amounts or the number of liters of each of these two substances. Okay? Well, right there, that gives me one equation. This amount plus this amount has to give me this amount. Together, the two liquids make 120 liters. But I'm going to need a second equation to solve this because I have two variables. So I'm going to need two equations. What's my second equation going to be? Well, let's make use of these percentages here. The top row shows the amount of actual substance. But what's going to happen if I take 120 liters times 21%? Or in other words, 120 times 0.21. Well, I'll get 25.2, but what is that? That's the number of liters of acid mixed into this substance. The whole substance is 120 liters, but only 21% of that is acid. Well, that comes out to 25.2 liters of acid are mixed in here. I can do the same thing for both of these to find out the amount of acid in each one of these. The only difference is I knew this one was 120 liters. I don't know these amounts, but it doesn't matter because I have these variables acting as substitutes for those amounts. The amount of acid in this is going to be the amount of liquid, X, multiplied by the 15%. So 0.15x. And the same thing here, 33% times y, or 0.33y. So that's going to give us our second equation, because the second equation is going to tell us that if I put together the amount of acid from each of these substances, I will get the amount of acid in the final substance. So 0.15x plus 0.33y equals 25.2 liters. Now I have a system and I can solve that thing to find my answer. We can use either method, either substitution or elimination. So let's go ahead and use substitution for this one. Okay. To substitute, I'm going to solve this top equation. I could solve either equation for either variable, but it's easiest to solve the top equation because the coefficients are 1. And I can solve for either x or y. So I'll go ahead and solve it for y. Doesn't matter. So to do that, I subtract x from each side. And so I'm going to get y equals 120 minus x. Okay? Now substituting that into the second equation where y is, I'll get 0.15 x plus 0.33 y, and y is now 120 minus x, equals 25.2. I have a one variable equation. I go through and solve it. So 0.15x plus, I'm going to have to distribute my 0.33. Okay, so 0.33 times 120 is going to be 39.6 minus 0.33 times x is still going to be 25.2. Okay, combine like terms, I will have a negative 0.18x plus 39.6 equals 25.2. Subtract the 39.6 from both sides. So negative 0.18x equals 25.2 minus 39.6, which is going to be 14.4. Sorry, negative 14.4. And then dividing both sides by this negative 0.18, what I'll end up with is 80. Okay? X equals 80, which tells me, since X is the amount of the 15% acid, this is 80 liters of 15% acid, which means Y, well, X plus Y equals 120, or Y equals 120 minus X. So 120 minus 80 is going to give me 40, and so Y is going to be 40 liters of the 33% acid. Let's see one more example of a mixture type problem. Cheryl Zavertnik won $60,000 on a slot machine in Las Vegas. She invested part of the money at 2% simple interest and the rest at 3% simple interest. In 1 year, she earned a total of $1,600 in interest. How much was invested at each rate? This involves a kind of different situation than the last one, but it's going to be handled very similarly. We're going to use the interest equals the principal times the rate times the time. But we don't need the time because it's talking about only 1 year. So when we put a 1 in there, the interest is just going to be the principal times the rate. Okay? So we have two different investments. So we're going to have two different principals, two different rates, and two different interests. So let's make a chart for that. We've got the 2% investment and the 3% investment. Okay? Principal, rate, interest. Okay? Now, we know the rate for one account is 2%, which written as a decimal is 0.02. The rate for the other is 0.03, 3%. Okay? we do not know the principal invested in either one. But what we do know, if we make another row here, totals, is that the total is going to come out to $60,000. Okay? But since we don't know these, we can label these to be our variables. So x and y are going to represent the amounts invested at each of 2% and 3%. Okay? This incidentally gives us our first equation. We put the two of those amounts together, we get $60,000. Now the interest, to get the interest, we use this equation. The principal times the rate is going to give us the interest. Okay? So 0.02x, 0.03y. And when I total them up, I'm told that I'm going to get $1,600 in total interest. This box just doesn't mean anything. We can't total these. That doesn't make any sense. But when we total the interests, we're going to get $1,600 in interest. That gives us our second equation. 0.02x plus 0.03y equals 1,600. So very similar to the previous one, we have x plus y equals some value, and then percentages of each one of those added together gives us some value. Okay? We can solve this by substitution or by elimination. We did substitution last time, so let's use elimination. I'll go ahead and multiply the second equation by 100 to get rid of the decimals. So that's going to be 2x plus 3y equals 160,000. And how am I going to adjust this top equation to get a cancellation here? Well, if I want to cancel x's, I can multiply by negative 2. If I want to cancel y's, I can multiply by a negative 3. I don't really care which one, so I'll go ahead and multiply by negative 3. I'll just pick one. No, I'll do negative 2. Okay, if I multiply by negative 2, I'm going to get negative 2x minus 2y equals negative 120,000. So when I add these equations, these will cancel. Negative 2y and 3y is going to make 1y. And negative 120,000 and 160,000 is going to make 40,000. I don't even have to divide anything in this one. Sometimes I will, but in this case, y equals 40,000. That tells me that the amount invested at 3% is $40,000. Okay? And my total, remember, was $60,000. So if I invested $40,000 at 3%, 60 minus 40 is 20. X has to be 20,000. And X is the amount invested at 2%. So $20,000 was invested at 2%.